we are going to find the IUPAC nomenclature of this structure we're seeing here. Now, this is not the actual question that was asked from this structure, but before we go to that questions, I want us to first know how to name this structure here. So, how can we know the IUPAC nomenclature of this structure? Now, the first thing, like you always know, is to find the longest carbon chain, which will become the parent name. So here, let's look at this. The straight chain here, we have 1, 2, 3, 4, 5, 6, 7, 8 carbon. All right, but if you look closely here, how many chain can you see? How many chain can you see? Now, this is the first one, which is a straight chain. We also have another chain. That chain is going to start from here, this place here, and then go all the way from here. It will corner like this. This CH, this C2 and H5 you'll see here, it is extended as bracket C, bracket dash C and dash C. Here we put H, here we put H, here we put H. And this other place we also put H and H. This is how it's supposed to look like. So it was now shortened as C2H1, 2, 3, 4, 5. You get. So even though it's a substituent, it is also a type of branching there. So let's put it back the way it was, C2H5. So now if you follow this chain, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There will be 10 carbon here. Atom. We also have another chain. We also have this one here. This one now is also C2H5, which it could also be a type of what? Chain on the parent chain. So here we now calculate C2, we just count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we follow this chain, we're going to have 11 carbon atom. Remember, we're looking for the longest carbon atom we are going to find in the chain. So now, if you follow this one, so this one now give us 11. There's also on that chain. From here now, you will go up to this place, or from this place, you will come down to this place. But this one will just give us 1, 2, 3, 4, 5, 6, 7. So the longest carbon chain is this one that is from here and cut to this other place. And this is 11 carbon atom. So what is the name of 11 carbon atom? The first one you know is what? Met. Second one you know is what? Earth. Third one, prop, youth, and so on and so forth. But when we reach on 10, 10 carbon is known as what? Decay. Now 11 is known as undecaying. Undecaying. 12 is known as do decaying. 3, tridecane. 4, tetradecane. 5, pentadecane. 6, hexadecane. 7, heptadecane. 8, octadecane. 9, nonadecane. That is, sorry, 19, I mean to say. 11 is undecane. 12 is the decane. 13 is tridecane. 14 is what? Tetradecane. 5 is 15 is what? Pentadecane. 16 is hexadecane. 17 hepta. 18 octa. 19 nona, and so on and so forth. So here now, since we have 11, which is undecaying, is the parent name. So what you are now going to look for now is what is attached to this parent carbon atom. And then we have substituent. From this chain here, from this row to this row, we have an attachment. We have this structure as an attachment. We also have this structure as an attachment. We also have this other structure as an attachment. Now, this is where we need to number it. We also need to number forward and backward. So if I follow this forward locant, I'm going to have that the first substituent is going to be on substituent 1, 2, 3. Remember, I'm counting this as 2 because we have 2 carbon. If I should extend it just like I did here, we won't have it as 2 carbon. So I'm counting it 1, 2, 3. You get. So if it is in that form. This substituent is on carbon 3. So from here we have first substituent to be on carbon 3, and the second substituent 3, 4, 5 to be on carbon 5, and the third substituent 5, 6, 7 to be on carbon 7. That is if I follow the forward locant. Then I follow the backward locant, you find out that this 1, 2, 3, 4, 5. The first substituent is going to be on carbon 5. The second substituent is going to be on carbon 6, 7. And the last substituent is going to be 7, 8, 9. It's going to be on carbon 9. And because of this, you find out that we are looking for the smallest possible number to assign to those substituents. If I should follow this forward lookup, I'm going to have, they're going to be on 3, 5, and 7. But if I follow here, it's going to be 5, 7, and 9. So this one has a higher value of locant than this one. So this smaller one is what you are going to follow. Hence, you are going to follow the what? Forward locant that gave this substituent the lowest possible what? Numbers. Now, there are some situations that we're going to look at priority. But in this case, since what was there was 5, 7, and 9. So when I talk about priority, you find out that this one is this one is for this one. And if I should follow forward, this same one is going to be on this one, and this same one. So no need of priority since these two substituents we're still going to be on either carbon 5 and 7. But then this other one, this other substituent will change from 3 to 9 if I should number forward or backward. This is going to be the substituent locant number. So in that case, I'm going to give preference to this one that is having 3 here, because these two here is still going to be on 5 and 7 either ways that I number it. So that's why I choose here. So on the procedure here, we are choosing this other side. Now, what is the name of this substituent? The name of this substituent is an alkyl family, and because it have one carbon, we call it met. Now, because it's an alkyl family, it now become methyl. It will become what? Methyl. Now, this one is also an alkyl family because it has carbon 2. It's called ethyl. To name it, we are going to look at the first letter of this substituent. This one is M, this one is E. In the alphabet, E comes first before what? M. So because of that, I'm going to write where I'm going to find M, this ethyl on the undecaying structure. So here I have that because I'm following this forward locant, I have that from here. Here is carbon 5, 1, 2, 3, 4, 5. I have that on carbon 5, comma, also on carbon 6, 7, on carbon 7 dash. I'm going to find an ethyl. I'm going to find an ethyl. Now, because there are two ethyl on this 5 and 7, I'm going to write it diethyl because they are what? Two of the ethyl. So now, this is a substituent I'm seeing on this substituent. Now, what other substituent we are seeing is this substituent, which is what? Methyl. So we have to also locate where that methyl is found, which we have located as 1, 2, 3. So it's on carbon what? 3, this structure over here. So we're going to put it as what? Dash. Remember, we separate number from number using a comma. Now, I want to write a number with an alphabet, we separate it with a dash. So here now, I want to write the number which this methyl is found. I will now write dash 3 on carbon 3 dash methyl. Now, I'm not going to use dimethyl because it's just a single word, methyl. So here, I've finished with the substituent. So the next thing now is going to write the parent name, and the parent name is written closer to the first thing or the last name you have mentioned, which is this methyl. So I'm going to write the parent name here, which is what? Undecaying. Now remember that this undecaying, it has N. The name is undec. 11 is undec. 11 carbon is undec. But undecay, the ANE here shows that this are having single bond. If there was a double bond, it just be on the king. You get, so the dick on dick is a single is a carbon name, while the ANE is a type of bond which is a single bond. So that is it, the structure naming. So don't forget to follow and create notification bell so when we're going to be doing other questions, the main question that GCE asks from this subject is going to be coming up very soon. So you're going to be notified about it. So don't forget to share. Also, WhatsApp me to join the online class 081 539 57022. Then you can WhatsApp me if you're on another step by adding +234.